is the IME 450 Fixture Design Project by Caleb Fairburn and Jonathan McDonald. So, our team had to design, manufacture, and test a CNC milling fixture for an FMS system. The system will utilize the Haas EC400 horizontal CNC mill pallet pool setup with tombstones. The fixture needs to hold the IME 450 MFGE bottle opener CNC Op 1 blank and allow the CNC machine to perform CNC operation number 2 milling operations. The fixture must be designed, built, and tested using the Mike 6 tooling plate, Mighty Bite, Fixture Supplies, SolidWorks, HSM Works, and the Haas CNC mill. Design criteria and constraints. Our fixture must be within the max aluminum base envelope. It must mount to the tombstone in the Haas EC400 with the pallet. The fixture must be indicated to the CNC machine axes. It must be capable of producing one part per loading cycle. The fixture must locate the part off the qualified datum services machine during CNC Op 1. The CNC blank size, dowel pins, and Mighty Bite fixture supplies are provided. Fixture loading and unload times must be under 1 minute. Finally, clamping forces must be greater than a safety factor of 3. Locating the Op 1 stock in the fixture, the face of the stock is first positioned against the top of the fixture. Then, the Mighty Bite rail locates the outside profile of the stock. Lastly, the pin locates the inside profile. So, as shown in the tooling force calculations section, the required clamping forces, even with a safety factor of 3, are still within the 800-pound limit specified. The finite element analysis shows a maximum deformation of just over 1 thou, which was determined to be negligible for the part being made. This design was selected because the smaller size makes it easier to store and move, while also having a polka yoke effect. This is because the Op 1 stock either hangs off the edge of the fixture or does not clamp at all when installed incorrectly. Now that the design has been solidified, here's the manufacturing plan that outlines how to produce the fixture plate in the CNC machine in addition to the tools needed. The CNC machine has 12 discrete steps here that total just around 8.5 minutes. Now, to demonstrate the CAD/CAM programming of the fixture plate, the tools and operations here align with the manufacturing plan previously defined. There are multiple contour paths, a pocket operation, drilling, including reaming and tapping, and a chamfer. Now the fixture has been machined, it must be trammed with the dial calipers loaded in the spindle as shown, to align the axes with the CNC machine. The fixture has been set up, let's talk about the cost. Shown are the calculations done to determine the final cost associated with the fixture, which comes out to just over $13.50. Over 90% of the costs come from engineering time spent designing the fixture. The remaining $123 accounts for materials and shop time. Let's finish off the video with some discussion of the fixture while watching it in action. The first thing to recall is that our fixture has an intuitive design for the installation of the Op 1 stock by making it visually obvious when the stock has been installed incorrectly. Is also safe and ergonomic, with a high safety factor utilizing the calculations and a quick installation. The part can be loaded right on the fixture, and only the Mighty Bite clamp needs to be torqued. The fixture itself is also easy to install into the machine, with the dedicated indicating band for quick tramming. If we were to be able to make an improved revision B, we would start by having an easier spot to locate the coordinate system, such as a small cylinder pocket on top. We would also consider a second dowel pin in the bottle opener section to prevent any undesired rotation of the stock. Currently, the operator must pay attention to the stock and check if it is fully contacting the Mighty Bite rail when loading. Overall, we are extremely pleased with our fixture's performance. We had fun and learned a lot while making the fixture. Thank you, Trion, for organizing the project. Have a great summer!